Hey, Pedro, thank you for coming in. We've done a couple of interviews before this. In fact, prior to the launch of your, you know, global bestseller, The Master Algorithm, which went through the roof. It was spectacular, the reception you got for it. Of course, you're really famous for, best paper awards and all these honors that you received. And you definitely have been a prominent force in the AI space, but really much broader than that through all the co-creation and really the invention that you've done for decades, right, in this space. So thank you for coming in, and we're going to enjoy sort of, uh, you know, getting an update of where you are today. So again, it's a real pleasure to have you here.
Thanks for having me.
Pedro, it's been so long since we've done an interview. I'm going to ask one of the early questions I asked many, many years ago, just as a reminder to the audience. And you got this spectacular career. You made so many different contributions with so many different honors. What were the three inflection points in your life that made you who you are today? And it could have been when you're 3 or 5 years old, could have been inside, outside of school. It could be um, moving from a geographical standpoint. It could be mentors you've had. What are those three really big things that shaped who you are and continues to be maybe the inspiration of who you are today?
Sure. Well, one of them was getting interested in AI, which happened in 1987 when I was maybe on my uh, junior year of college. I just saw this book in a bookstore called Artificial Intelligence, and I wonder what that might be. It seemed almost like an oxymoron, artificial intelligence. It was actually the first AI textbook ever by Elaine Rich, and it was a small thing, 400 pages, small format. And I read the book and I realized a couple of things. One was that this field has an enormous potential, right? If you can really make progress in AI, that will have impact across almost everything. And the other one was that the state was so primitive. In particular, I immediately realized that machine learning was the key. Without machine learning, it'd be very hard to get there. But with machine learning, we really could get there. And the state of the art machine learning was very primitive. So I thought, wow, here's a field with enormous impact and where the state is very primitive. So, that sounds like a good thing to go into as opposed to a more mature field. So I got more into it, and I eventually decided to get a PhD in AI, which led to the next thing, which maybe was which was just to come to America, right? I came to America because this was pre-web. I made a list of places that were very active in machine learning. There weren't that many. There were only a couple of universities that actually, most universities had zero people doing machine learning. The only two I found that had some significant number was CMU and UC Irvine. I applied to them. I got into UC Irvine, and I came to the US, and I never looked back. Um, Initially I wasn't planning to stay, but I fell in love with the country. I met my wife, and those two things together, and like, if you want to have impact in the computer industry, this is the place to be. And then maybe the third one was when I got, and again, this really happened not that long into my PhD, was uh, I, I I realized this notion that really what is behind the master algorithm, my previous book, which is that what you really need to do is not just push one of these paradigms like deep learning or symbolic AI. Each one of them is solving a different part of the problem. So if you want to solve the whole problem, you have to unify all of them. Which, for example, to people in other fields like physics is, yeah, of course, right? We don't say that everything is gravity and we should ignore electromagnetism. Right? So, I think the combination, and then I set on this whole research journey that started with my PhD, where I unified symbolic AI and analogical reasoning. I'm probably best known for Markov logic, which unifies probabilistic AI and symbolic AI. Lately, I've worked on a lot on combining that with neural networks, and on combining symbolic AI with neural networks. And I think, myself and others that are working in this area, we're making enormous progress. And I'm actually more convinced than ever that this is where, this is what you need to do.
there's some really interesting things like categorical sort of algebraic sort of ways of thinking. Oh, excuse me. There's the Kolmogorov-Arnold network. Looks interesting, though there isn't hardware. What are your sort of feelings about some of the new models that are coming out, and they have some parts of kind of transformers, but really they're really in their own separate categories. Very much, I would say, aligned with your ideas that you've had for decades. So, what do you think about some of these new ones that are out, and what do you think about the promise of them? And then what's on the horizon that you think is really exciting and interesting?
Well, transformers, I guess at this point they're not that new. They're what, 7 years old, and the tension is almost a decade old. But it's interesting because number one, I think they are the closest we have come yet to the master algorithm. Right? In many ways, my predictions in the master algorithm are already coming true. Right? You have this one algorithm, essentially, if you boil it down to the essentials, that does all these different things in language, in vision, and in everything. Right? And also, I think the more we understand transformers, the more we realize that what they do is they bring features of symbolic AI to a neural network, and that's why they're so powerful. What is a transformer? It's a learnable key value store where you can learn to address things and then pick them up and use them using backpropagation. And this, we had gradient descent before, which of course is the number one method used to learn machine learning models, although not the only one. We also had key value stores, right? We've had those for a long time. What we didn't have was an easy, flexible way to learn the latter using the former, and now we have that. Now, on top of that, if you look at where the action increasingly is today, it's in things like doing reasoning, doing discrete search, doing Monte Carlo tree search, and again, a lot of symbolic stuff on top of transformers. You could even say that, if you look at things like O1, there isn't that much happening with the transformer stuff anymore. That's kind of settled, maybe not permanently, but at least for now. And again, this notion that you're going to combine neural and symbolic AI, which a few years ago might have seemed a little dubious. Really, this is what people are doing at this point. So what is happening now that I think is exciting? Well, neurosymbolic AI is one of the things, as you might expect. And it's interesting because neurosymbolic AI is combining symbolic and AI and neural networks. And people think this is a new idea, which is very ironic because, first of all, even a few years ago, it had a brief period that people were like, okay, let's do this. And it was getting more and more attention already in very much in the deep learning area. And by that name, it's been around for 20 years at least. And in fact, in the late 80s, in the previous wave of neural networks, there are a bunch of people working on what they call connectionist symbol processing, which was symbolic AI by another name. Like, Jeff Hinton edited a special issue of the AI journal on this. A bunch of people, including him, worked on this because at the time they thought they were important. In fact, in grad school, one of the first classes I took was models of the brain, and my project for that class was on connectionist symbol processing. So this thing that seems to be new is what, 30 years old. So that's one thing. Another thing, funny that you mentioned group theory, is I think that at the end of the day, even after we've unified these paradigms, we're still not going to have the complete answer. I can't prove that. Maybe we will, but my guess is we'll still need other things. And I think one thing that we very much need is, I think, the whole area of symmetry group theory, which of course in mathematics is super important and is the foundation of modern physics, right? The standard model is a bunch of symmetry group theory, right? I think we're going to need that in AI as well, for reasons that we could go into. But, AI has these three legs in mathematics right now, if you will. There's logic, which of course has been there, since the 50s and is the foundation of symbolic AI. There's probability / statistics, and there's optimization. And I think the fourth leg of the stool is symmetry group theory. So the two main things that I've been working on lately are, one, what I call symmetry-based learning. It's also called geometric deep learning by some people, although I don't think that's the best name because it's neither just geometric nor just deep. And neurosymbolic learning, and in particular, I have this approach called tensor logic, which combines logic programming and tensor algebra, which are respectively the foundations of symbolic AI and of deep learning.
So were you at NeurIPS recently, or?
I didn't go to this NeurIPS.
So are you a fan of NeurIPS? Maybe.
I like NeurIPS. I've never gone every year. My favorite machine learning conference has always been ICML.
Right.
Which I mean, and it's very interesting how things change. So when I got into the field, ICML was the symbolic AI learning conference, and NIPS was the neural learning conference, and the others, there are a few other things, but those were the main ones. Back then, there was almost nobody that attended the two. There were half a dozen people, including me, right? And now this is the funniest part, though, is that when I started going to NIPS, and for many years, until maybe 10 years ago, NIPS was the conference of people who did stuff on a small scale that didn't really work on large scale real problems because it was all done in MATLAB. And it was very theoretical, right? It was sort of like this mathy, sort of like machine learning papers gratuitously decorated with math, right? And it was also very trendy. Like in ICML, what I really liked about it was that it had a very strong experimental leg. It's like, we don't want your paper unless you have very good experimental evidence that it works. Whereas at NeurIPS is like, if you have some cute math, then, no matter, the experiments can be whatever or almost nothing, right? It's funny to see how that's changed, right? These days, in terms of content, there's really not that much difference between the two. It started with support vector machines that sweat both of them, and then, you could publish in either direction. And of course, NeurIPS today is just full of very large scale stuff. And a lot of people who think that, large scale machine learning was discovered in the last 10 years. So yeah, I mean, I like NeurIPS, but I think it's important to not get overly focused on the type of research and sort of like the general attitude that prevails there. Also, sorry, let me mention one more thing. These days, NeurIPS, and unfortunately that's also true of ICML and KD and so on, it's so large. Right. It's hard to get a lot out of it, right? I mean, like, I went through the papers, I went through the invited talks, the workshops, the tutorials, et cetera, et cetera. And, like, it's odd that what's happening these days in AI is that there's more research than ever, but it's also more narrowly focused than ever. And I feel that almost all of what happens there is not that relevant to the direction that I'm going in, unfortunately, right? We need to diversify the research more. Also, most of the value that you get at a conference, as you well know, is talking to people in the halls. But these days, it's such a sea of people, most of which are really just, curious or getting into AI, or were told to go there by their bosses, that it's actually hard to just, run into the people that you really benefit from having a conversation with.
I mean, what do there's this kind of different areas that the AI folks are in, or machine learning folks are in, right? You have Jan LeCun, and he's kind of has his own sort of thinking, and then you have Jeffrey Hinton has his own kind of thinking, right? And also Joshua Benjo's kind of maybe more on the Jeffrey Hinton side. Jeffrey Hinton left Google last year, so he could go on the road and just kind of talk about his views of what's happening. And then, of course, he just won the Nobel Prize in Physics with Hopfield, right? And some of the early work that they've done, which is really remarkable for computer scientists and AI, to get that kind of recognition, though it created some controversy. And then, of course, you had on the deep mind side, David Baker and John Jumper and Demi, of course, winning the Nobel Prize in chemistry, or the application of amino acids folding into these 3D protein structures based on existing chemistry, and then understanding what this protein structures are, and then, of course, more on the synthetic side. Can you produce new kinds of proteins? That's quite probably more David Baker. But let's talk about this sort of work. Like Jan LeCun, are you kind of aligned more with you would be more aligned with Jan LeCun then, and then Jeffrey Hinton sort of off on his own, but he's got other people that support his way of thinking, right, as well. So,
well, so we should distinguish between two different things. One is the research that they do, and another one is their views on the future of AI.
Right.
And I would say that on the research side, I have points of contact with all of them.
Right.
So they're all different. And they've all made very different key contributions. And I think they're all important. And in fact, part of why I think the field has succeeded is because they have contributions from different people, like all three of them. Jeff Hinton is the most brilliant, the most creative, the most ambitious of the three. Almost too much, right? He wants to understand how the brain works. He famously says that, every few years he comes up with a new theory of why the brain works, bolts and machines, help with machines, et cetera, and they never work in the end. But in the process, right, he spawns all these things and works with all
Right.
these people. Like, he's been involved in more of the big advances than almost anybody, like from backprop to AlexNet and so on. But Jan he's sort of like a really solid engineer, right? He's actually done more to make neural networks work than anybody else in the world. In fact, when Jeff Hinton gave an impromptu talk at NIPS 2012 on AlexNet, somebody asked him, so what did you do to make this work? His answer was, every trick that Jan ever came up with plus a few new ones. So that's true. So you shouldn't forget that. Yoshua Bengio is the most eclectic of the three. Right, he looks the most outside of the narrow deep learning community or neural network or connectionist, and in fact, he's done a bunch of follow-up to stuff that I've done, for example, and very quickly, right? He's like, in terms of just sheer amount and diversity of work, he's done the most. He was also always the one who had the most interest in language. Back when mostly people focused on vision, right? Jan and Jeff mostly focused on vision throughout their careers. Jeff did some speech, but mainly it was vision. And in fact, it was out of his group that attention came, right? So the current LLM wave really owes more to him than to anybody else. And what I do has points of contact with all of those things. I do agree with a lot of the things that Jan says in terms of no, LLMs are not the final answer, et cetera, partly for reasons that we already talked about. However, I have strong points of disagreement with him on, for example, Jan thinks that gradient descent is the master algorithm. He thinks backprop is all we need. And I just don't see how that makes sense. I asked him this question, so if gradient descent is all we need, how did Einstein come up with relativity by gradient descent, right? And there's no answer to this, right? So I do have some disagreements with him there. Then there's something that is very much in the news today, but maybe is less important that someone just reading the news might think, which is, what are the risks of AI and whatnot? And I think there, Jan is definitely the more sensible one. I tend to agree with him when he says, you just calm down. AI is not getting out of our control. I think some of this has to do with the fact that both me and him are electrical engineers by training, and we're less prone to flights of fancy. Honestly, I think, Joshua is a very well-intentioned guy, but he's extremely naive. He has this picture of the world that, is just not, an academic can be like that, but I wouldn't follow his advice on real-world issues. And, Jeff Hinton is just, he's very, he's just got his own ideas and he's very frank. He used to be on the, so Joshua was always more alarmist. Jeff was more on the fence. And in fact, I remember talking with him at one point, and I forget what this is apropos, but this is sort of prior to the current wave. And he said he was AI in the end is going to make the world a worse place. And I was like, what? And he said, yeah, because the corporations are going to take control and use it to exploit people. He's ultra left, right? He's ultra left, beyond socialist, like a narco or something, which, he's entitled to be, but his view of the world is very influenced by this. And I was like, well, but Jeff, if I thought AI was going to make the world a worse place, I wouldn't be working in it, right? So why are you? And he shrugged and said oh, I don't care. I just want to understand how the brain works.
Yeah.
It was only recent in the last couple of years that he had this, awakening or epiphany, if you will, that, well, suddenly, because of, ChatGPT, AI seems close, and maybe we should worry about AI taking over and whatnot. But he himself says that his ideas on this are not very mature, and honestly, he doesn't know that much about how this whole side of issues. So by his own admission, his opinion actually is not that informed, and honestly carries a lot more weight than it should, just because he's Jeff Hinton.
Yeah, I mean, he's done all of these talks this year, at Oxford. I mean, he's been everywhere, right? And then he's done more because of the Nobel There's Ilya Sutskever, though. I think he's really an interesting sort of practitioner in essence, right? What are your thoughts on his work and the direction he's gone? And of course, he's left OpenAI, and he was a grad student with, when they went to ImageNet, that was Jeff Hilton and Alex, right? So, and then he's been with some major groups, and he's gotten a lot of attention, right? So, what do you think about Ilya Sutskever management?
To be very blunt, I think Ilya is just a guy who got lucky. He was in the right place at the right time. And then, he's become extremely successful. He's not, to be very honest, he's not a brilliant mind like some of the people we've been talking about, even someone like Denis Hassabis, right? He's like, I'm consistently surprised at his lack of insight about things, honestly. And I think as OpenAI chief scientist, he was in over his head, right? And they were flailing by their own admission, including his, I think. And then they hit on this LLM thing, and to their credit, they ran with it. But again, it was just the same logic of scaling things up that they pursued yet again, and they were more really by rights. Google should have run away with it because they really did most of the work, right?
Yeah.
After the stuff from Montreal and so on, but they didn't, and OpenAI did. A lot of that is to the credit of Sam Altman, who's very aggressive and very good at what he does, which is not AI research. It's more being an entrepreneur and whatnot. And Ilya, I think, of late, to his credit, he's realized that this whole scaling up has run out of runway, whereas people like, for example, Dario Modi think that scaling up is going to get us all the way there. I don't see him having any ideas that I've seen yet on how to get there, right? I think he's looking around at various things like, quantum computing and whatnot, and seeing what he can pick up, which maybe he will pick up good things, and I hope he does. But I think people tend to, again, they give more credit to Ilya's opinions on a bunch of things because he's been incredibly successful. Yes, he has. But, when you're looking at people's success and whatnot, and how much to believe the direction they're going in, you always have to ask yourself, how much of this was their insight? How much was luck? I think, in Jeff Hinton's case, I mean, there's always luck, but, he has 40 years of pounding on this and being creative and whatnot. And Ilya, I think largely he was very lucky, which there's nothing wrong with, but, we should be clear about that.
But yeah, I mean, you put Demi Hassabis in a different category, right?
I do think that Demis is really smart.
Well,
He's maybe in a way that is not necessarily very appreciated. He's done good research. So the real talent that Demis has displayed is in how to build a research lab for the modern age. DeepMind is actually an incredibly well-conceived and well-run research lab. And like OpenAI, which, is a very chaotic and random and again, in my new book, 2040, which is a satire of Silicon Valley, there's a startup called Kumbaya that is a spoof of OpenAI because there's just so much to have fun with there. They got lucky, but largely it was by, getting lucky. Whereas DeepMind, they've had this strategy like almost since the beginning of how to run research. And, we could go into the details of that, but I think Demis has done that very well. The paradox is that there's two things. One is, in the early days, he went around saying like DeepMind is the Apollo project of AI. And I remember thinking like, I just wouldn't have the nerve to say something like that. And he doesn't anymore, I don't think. But it worked in terms of attracting a lot of really good people, right? They have more good people than and a better, lab culture than almost anybody else. So that worked, even though really it was misguided. But it was no different from what the founders of the field did, right? Minsky and McCarthy and Newell and Simon in the 50s, they went around saying like, we're a decade away from human level AI, right?
right.
And they were crazy, right? People said they were crazy, and they were, but that's how they started the field. So, maybe a certain kind of craziness is actually helpful. The other thing, though, and maybe more on the scientific side, is that the bet that they were making very openly so and prominently so was on deep reinforcement learning, and that did not pay off. Their strategy was like, we're going to start by doing these things in games and, and simulation and whatnot, and then we're going to scale up to real robots and whatnot, and that still hasn't happened. So they got famous with Atari and then AlphaGo, and now more recently, of course, the protein folding stuff. The protein folding stuff is a real major contribution that the Nobel Prize was well deserved, along with my colleague here at UW, David Baker. But that doesn't have anything to do with deep reinforcement learning anymore. So they were very successful, partly by being overambitious and despite in some ways having made what so far seems like the wrong bet.
You have Demi running now Google AI, and in fact he's taken over Jeff, right? Jeff Dean, who for years was running it basically, and then in Google Brain, and then he's supplanted him in essence, right? And then you have Mustafa, CEO of Microsoft's AI. But who's the winner there, with Demi and Google, or Mustafa with Microsoft?
Oh, sure. Well, let's talk about Mustafa first because it's easier. Mustafa is another one of those guys who got lucky, right? He's the Ringo Starr of DeepMind, right? He's just happened to hang out. Like Mustafa's where again, I have nothing against him, right? But, I believe in trying to see things clearly. He was like the younger brother of a guy who was Demis's colleague in high school or something, and so he wound up being one of the co-founders of DeepMind, along with Demis and Shane Legg. Really, I think just because of that, right? By background, by what he can do, like he really, and then the thing is that's most ironic is that his story so far is one of consistent failure. I can't think of a single product that he ever shipped. Nothing he ever did at DeepMind succeeded. He left. Nothing he did at Google succeeded. He had problems at both of these with conflicts and whatnot. He also has this, again, on sort of like the AI alarmist side. He's like this, some AI alarmists are actually more informed people that are worth, thinking about their criticisms. This tends to be one of the more vacuous ones, honestly. And then, of course, the hilarious thing in all this is that Satya Nadella decided to hire him to be AI, the AI CEO of Microsoft, which it sounds like an absurd thing to do. And I said at the time, a bunch of the people who are going to have to report to him are going to start leaving, and they have. That's what I would do if I was there. And, we'll see how things turns out. You can also debate, why did Satya Nadella do that? And were there good versus bad reasons? But that's another subject. Now, Jeff Dean. So I've known Jeff for a long time. He's actually an alumni of my school of UW. And he's a brilliant technical guy, right? As a software engineer, he did amazing things like map the whole scaling, things up to, data center size, which we take for granted. He was really one of the main people that made that happen in the early days at Google, but also one of the main people, honestly, who failed to turn that into a large scale thing for everybody, not just Google. It was very inward facing. And then Amazon came and ran away with it, right? And again, Google has had this problem over and over again. And part of it is Jeff, right? Also, he became someone with a lot of prestige within Google. And I think he's given terrible advice to Sundar on a whole series of issues where Sundar has gone on to make one mistake after another. So you have to distinguish Jeff, the technical guy, from Jeff, the manager. Jeff, the manager, is not that great, right? And in fact, I remember asking him at one point, how do you manage Google Brain? And he said, oh, I don't. And that's the problem, is that Google Brain was never very well managed. They hired a bunch of brilliant people who wound up not very motivated and envious of DeepMind, right? DeepMind and Google Brain famously didn't get along very well until, Sundar jammed them together. And guess who's in charge? It's Dennis, because what he does, he's the one who really knows how to manage a large research effort. And Jeff was never really that good at it, or maybe interested, but, Google paid the price.
It's interesting, Pedro, from our last two interviews, you definitely are expressing your opinions of the people over. How about Andre Kabard, had these pretty senior roles, and he's left. And
who's sorry?
Andre Kabard.
Oh, Andre Karpati.
Yeah.
Yeah. I don't know him that well. To be honest, I think he seems like a very competent, very thoughtful guy. He's done a great service to the community with the videos that he's put out and the effort to educate people on how to do deep learning. I think, that's probably what he's best known for and has a following for. And indeed, that has been a great service. And then he seems to be so to unfairly divide the world into kinds of people, right? There's the visionaries like Jeff Hinton, right? And the visionaries are very exciting, and they can have great ideas and they're worth listening to, but they often do not give you a realistic view of the world, right? They have a reality distortion field, like Steve Jobs, right? That expression was coined for Steve Jobs, and he seems very much like he was that type. If you want to see things as they really are, you need to talk to a different type of person, right? Who have less of an agenda and then kind of like more level. And Andre seems to be of that form. So, if you're a company and you want advice on AI, he might be one of the people that you might want to talk to. Maybe, even more. I mean, people like Jeff and so on are worth talking to because he just knows so much, right? But his particular opinions are something you have to take with a grain of salt. So Andre seems to be good in that regard. In terms of, and he, at Tesla, he built up the whole, deep learning effort and whatnot, which seems to have been very successful. So that was important. Having said that, I'm not sure that I buy some of the choices that Tesla has made. And the truth is, I think those came from Elon, but Andre bought into them. And we'll see how things turn out. But I think Waymo is still, way better than they are. Of course, they also had a head start, but I think, they've also been sort of like, they've had overall a better approach. So just purely on the research side, I can't put my finger on something that's like, well, here's an amazing, contribution that Andre has made. But, that's only one of many aspects.
You see Gary Marcus in the news a lot.
Yes. Yeah. I'm already laughing, so what can you do? So sorry, what is your question? What do I think of Gary?
Well, Gary's very vocal, and he has he has a following, and he definitely has a point of view, and it's not aligned with some of the other researchers that are out there, right? So, what are your views on Gary's work?
So I actually know Gary quite well. I've had many interesting discussions with him, for a long time, even before he had his first startup and whatnot. And again, like all these people, Gary has an interesting history, and you have to understand the history to know where he's coming from and where he's going. Gary was a student of Steve Pinker. He's actually a developmental psychologist. His PhD was on how children learn. And back then in the 80s, Pinker and Prince and whatnot, they had these criticisms of what deep networks can't do. And then Gary picked that up and ran with it. And they made his life hell. They tried to really make sure he couldn't get a job. And he still has he really has it in for them, right? He may try to downplay that, but really at the end of the day, he hates their guts and they hate his. Having said that, what I'm always saying to people is, I know that Gary can be very annoying, and really a lot of people they can't stand him, from Jeff Hinton on down, is that, look, every field needs its knowledgeable critics. And the more hype the field is, the more it needs those critics. I need people telling me why machine learning is full of, hot air and whatnot, as long as they're intelligent criticisms. There are a lot of dumb, uninformed critics of, wow, there are so many today, right? Which is why someone like Gary is valuable, because he's actually an informed, knowledgeable critic. And some things he doesn't know as well as he should and so on. But overall, a lot of his criticisms of deep learning are on the mark and have been on the mark. He overplays them and exaggerates and whatnot, but we have to forgive him. That Jan is always saying, he's had this, him and Jan, were both at NYU for a long time. And they clearly, they've had a fight going on. I'm not going to say they can't stand each other, but to some extent that's true. And Jan is like, well, we'll take your criticisms when you start building your own systems. And I'm like, whoa, right? If we engineers only take criticism from other engineers, we're doomed, right? We got to take, and mostly, in any field, the best critics are often people who come from adjacent fields. And cognitive psychology is an adjacent field to AI. So as far as criticisms of deep learning go, he had the book criticizing deep learning, and I wrote one of the blurbs saying, every CEO should read this book, because they should. They need to know the downside as well as the upsides. And, we've been seeing some of that play out. Now, at one point, Gary decided to make this career change from being a critic of deep learning because it's never going to work to being a critic of deep learning because it's too dangerous. And honestly, I think the latter, to me, just smacks of opportunism. It's shallow. His criticisms of deep learning there are not, or of AI more generally, are not better or more convincing than those of many other people. So I think there's three Garys. There's Gary the researcher, which these days is really not that relevant. And honestly, all of that never amounted to much. There's Gary the critic of deep learning, which I think is worth listening to. And Gary the critic of AI, who honestly, I don't think he's adding anything useful.
So Pedro, I mean, you've been this proponent of this master algorithm. You wrote a book, and ultimately your idea was to have a master algorithm, which is in essence kind of aligned with this idea of AGI, right? Artificial General Intelligence. So where are we in your work, and then where you think it's going with the thinking that's out there? Because there's some people who are saying it's in the near term, right? Even Anthropic, the CEO, is saying maybe it's going to be really soon, and then there's other people say kind of mid, and there's other people who are saying maybe 10, 20 years. I mean, where do you sit, and who are the leaders?
Right. So there's a couple of different questions here. One is, how close are we to AGI? And my answer to that is we are 100 years from AGI, give or take an order of magnitude. Which means we could be 10 years away. I don't think we're less, right? Even if someone came up with a master algorithm today, it would take at least a decade for things to play themselves out. And on the other side, it could be 1,000 years or more, right? Some people say it's just too hard, or there's fundamental reasons why it's not going to happen. I do think it's going to happen, but I think how soon it will happen is really uncertain. Anybody who gives you a very precise date doesn't know what they're talking about. And the reason is very simple, is that technology progresses by S-curves. Right? There's periods of rapid progress, and then there's periods of stagnation. And we are obviously now in the period of most rapid progress AI has ever seen, but there were others before, and then there were periods of stagnation, or slower progress, if you will. It was never complete stagnation. And chances are we're going to reach another plateau. In fact, people like Ilya and whatnot say we're reaching that plateau now, right? I have a funny story about that, but we can hold off on that. And we don't know when the next big, so like some people say, people like Dario say, well, this is going to take us all the way there. Right? This is what he really thinks is, we're just going to keep doing more of the same. And that goes to AGI. People like me and Jan-Lukun and most of the community, we don't believe that to be the case, right? This is just an illusion. But then if we do plateau, then when is the next big improvement going to come, and where's it going to come from? How many do we need? That honestly, we don't know. And it really just depends on us, right? If we have brilliant people who make great innovations in the next couple of years, we'll keep going, or we could get stuck for another 50 years. Who knows, right? So there's no really way to know that. Now, on the question of where are we and what do we need to do? I mean, I think if you look at the master algorithm when it came out versus now, it's in some ways, I think it's a prescient book, because at the time, many people said like, oh, a master algorithm. Oh, come on, right? Like, I did this interview to this PBS station, I think in San Francisco, where she said like, you're completely crazy.
Yeah.
You didn't tell me I was completely crazy. Thank you for that. But there was some people, and in fact, I did a poll of a bunch of people when I was writing the book. So like, do you believe in this notion that is one learning algorithm that is what we need for AI? And, there was a spectrum of opinions. Most practitioners thought no, because their daily experiences of having to try many different things. But there were two people who gave a strong yes, and they were, guess who? Jeff Hinton and Rich Sutton.
Yeah.
Of course, what they thought was the master algorithm was different things, right? For Rich, it's reinforcement learning, and for Jeff, it's whatever, some form of deep learning. And this year's, form will be, it's forward, or it's capsules, or it's, whatever. But he does believe in that notion. But I mean, look at transformers, right? A transformer in some ways is remarkably closer to the master algorithm than we were 10 years ago. It's one algorithm, right? Of course, there's variations. This is an 80-20 rule, but it's an essentially one algorithm, one architecture, one set of things, working together, and it does everything, right? It doesn't do everything equally well. People try to do it, people overuse it like they overuse everything, but really, right? It's truly remarkable what a single machine learning algorithm does. So I would actually say at some level, that argument is settled, right? I don't think I need to argue that there's a master algorithm anymore. It's, we can already see it coming, right? And in fact, as I said in the book, the human brain is the master algorithm. So unless you believe in something mystical, if we can reverse engineer it, we're there. Or, excuse me, evolution, right, is also a master algorithm that, we can express it as an algorithm. In fact, that's what the whole evolutionary computing school of things does. So I think there is no doubt in my mind that we're going to get there. The question is how, and that I think is still very open. I'm pursuing one approach or a couple of approaches. My main disappointment with the research community is that there aren't thousands of people pursuing thousands of approaches, and that really we're concentrating all of our effort on just doing incremental improvements. Really, 99% of AI research today is incremental improvements on transformers, which are all very fine from an industrial point of view, for the short term. But I think for the longer term, honestly, most of them are going to be a complete waste of time.
You decided to do this latest book, 2040. So what inspired you to do this work? And from a career standpoint, the last time we talked, you were still actively as a professor, but now you're emeritus. So can you describe that journey and then get into your book and what you hope to achieve with your book?
Sure. So I like to tell people that when I was a full-time professor, research was my hobby. And now that I'm emeritus, I can do it full-time.
Yeah.
And that really encapsulates my reasons for going emeritus. I just have more time to do research. I think AI is a marathon, not a sprint. And I think someone really needs to take their time and really go deep into the problems, as opposed to just trying, when you're a professor, you have to do 100 different things. You're constantly context switching from one thing to another. That ain't the way it's supposed to be, right? The system is broken. But in the meantime, I decided that I was better off just jumping outside the system and not having all that pressure and all those things that I have to do, some of which I like and like I like to teach, for example, but you got to prioritize. So I went emeritus to just be able to focus full time on, running this marathon. Solving AI is a marathon, not a sprint. Too many people are running sprints. I'm going to run the marathon. So that's what I've been doing. But in the meantime, just for fun, I wrote this book called 2040. And what is 2040? Well, as the subtitle says, it's a satire of Silicon Valley, of the AI hype and fear, of the tech industry in general, of how that plays into the general culture, the cultural wars and politics. So the plot of 2040 is basically that ChatGPT runs for president. And as soon as I had that idea, as you can imagine, the jokes just started writing themselves, right? One after another. It's funny because I had the idea of this before there was ChatGPT. Right? So then I had to explain to people what this was. And now I can just say, ChatGPT runs for president, and they immediately get it, right? Now, why did I write that book? Honestly, because I couldn't help it. It was just so much fun. And the ideas just came one after another. But on top of that, right, there's also the more rational reason of at the end of the day, I spent a good chunk of time doing that. And I try to maximize my impact. What is the impact of writing that book? And it's a couple of things. One is that I really do think that AI needs demystified. Right? There are too many people, from CEOs to politicians to people in their daily lives, in their professions, who they would really benefit from understanding AI a bit better. And that's why I wrote the master algorithm. But talking to all these kinds of people in the sequence of the master algorithm, I realized that often the best way to convey something is not to write a long technical book about it, is to tell them a story that illustrates the point. That's the way it best, sinks into people. And in particular, there is this image that underlies a lot of these fears and discussion about AI of Terminator, Skynet, right? It's the Skynet fear. And what I'm trying to convey with that book is that is not what AI is like. What AI is like is the AI that runs for president in 24, it's called PreziBot, the presidential chatbot, and that's AI how it really is. With all the messy, engineering decisions and the hacking and the things that go wrong and the hallucinations and the et cetera, et cetera. So I'm just, in some sense, visually illustrating, narratively illustrating for people what AI really is like by showing them the lives of the people in the startup that is creating this and and the problems that they have to solve, and the things that go wrong, and so on. So if the only thing that people take away when they read 2040 is that when they picture AI, instead of picturing Terminator, they picture Prezibot. That's, the book is already doing its job, right? The other thing was that I've always felt that someone should write, a novel about the tech industry. Like, Tom Wolfe in the 80s, he wrote The Bonfire of the Vanities, which is often considered the greatest novel of the 80s, which was a satire of Wall Street, back when Wall Street was the iconic industry of its time. And now the iconic industry is Silicon Valley, and someone needs to write that satire. And the beautiful thing about Bonfire of the Vanities, it wasn't just a satire of Wall Street. It was a satire of the whole world, of New York, and the politicians and the activists and the journalists and everything, and that whole ecosystem. And I tried to persuade some of my journalist friends covering Silicon Valley, whose secret hope is to write the great American novel, that what they should try to do is write the great Silicon Valley novel, because that's so much easier, and there's the territory is less covered. But they never did, which again, like the master argument, made me eventually think, well, maybe I should write this myself, because I also learned to write fiction back, when I was a grad student. I went to this famous program called Clarion West, where they teach you to write science fiction. I kind of knew how to write, at least at some level. And then the trigger for this was that a journalist, this was maybe in 2018, asked me, so if an AI ran for president, would you vote for it? And I thought, interesting question. And my answer was, well, it depends on who the other candidate is. If the other candidate is bad enough, then the AI becomes, the least of evils. And that, that for a while just sat there. And then circa to 2020 was when sort of like this idea started to grow in my mind, right? Before that, there was too much happening. And also in 2020, sort of like on the political and cultural war side, it was when all these other things happened, like these, the riots and so on. And I was like, and then I realized that having your startup create, so like, a novel about the tech industry should be the story of a startup, right? That's obvious. But then what does that startup do? The dirty little secret of Silicon Valley is that most of what we do there is very boring. It's very mundane, right? It's plumbing, right? It's like, oh, my startup has a new, better algorithm for, check handwriting recognition. We're going to change the world, right? It's, that's the reality. But if your startup is one of the, what if their demo, right? Prezibot starts as a demo, which is part of the joke, right? But the demo winds up being the candidate of one of the major parties. At that point, there's a lot at stake. And literally, there's the future of America at stake, because the other candidate is a fake Native American chief who wants to abolish the United States and give the land back to the indigenous nations. So, at one point, he runs into this truck driver and asks him, so who are you going to vote for? And he says, well, if I vote for Raging Bull, the other candidate, it's the end of America. But if I vote for Prezibot, it's the end of the world, so I have to choose the least of evils. So in some sense, those are the stakes here. So, there's also an element, part of the motivation for me in writing this novel is to not talk just about AI, but about the tech industry as a whole and how that interacts with politics and society, which, again, I think there's a dire need for a more enlightened conversation about.
So what has been your feedback so far?
The feedback has been, the short answer is really good. But to preface that with, when you write a novel, you have no idea how good it really is, right? You like it, or you wouldn't have put it down. And I, as I said, I really enjoyed writing it. But the feedback from the people who've read the novel so far has been honestly spectacularly good. Now, to dig down to a deeper level of detail, if you look at, for example, the reviews of the novel on Amazon and Goodies and whatnot, it's interesting because they're bimodal, right? Most review distributions are unimodal. This is bimodal, and the mode is the biggest mode is at 5, right? There are people who say like, oh, I just love this novel. It blew my mind. It's so funny. It's just like there's something funny on every page. And by the way, I try to have the novel be entertaining and funny and a quick read, but at the same time, every single element in the novel is illustrating something real. It illustrates the startups, the tech billionaires, the everything, right? So like everything is there for a reason, down to the smallest things. And people feel that. They're like, oh, wow, I just had a lot of fun for 2-3 hours, and I learned so much about the tech industry. So there's a lot of people who love the novel for that reason. Then there's people who have, but for the most part, there has been almost nobody, again, even in these public reviews, which are less biased than, if you will, just someone talking to me. There hasn't been anybody saying like, oh, this is terrible, right? There are people who have various complaints about the novel. That it's, and probably the most common one is that, well, this is too over the top, right? And the novel is a satire, and yeah, I mean, it's sort of like, it's deliberately over the top. To some people, it was too over the top. And some people are like, oh, this is such a pessimistic vision of the future. And well, yes, a lot of disasters happen in that novel, but if you read it, you'll see that at the end of the day, it has a positive message. And of course, the disasters in some way are all the things that could go wrong with AI, rather than the obvious Terminator one, which of course is not, like I have a pinned tweet about the novel where, with a point through that says like, AI is not going to take over the world. It's much worse than that. So these are the things that could happen that actually are worse than what you might be thinking. So it is pessimistic in that regard. But at the end of the day, right, the novel is, it's 2040 is not a prediction of where we're going to be in 2040. It's, I often say to people, I have jokingly, that the novel will have been a success if it helps the world be unlike what it depicts. Right, so the novel is more of a caricature of 2040, trying to point out to people that if we keep going in this direction, things are going to go bad. So hopefully it helps motivate people going in a different direction, both in terms of AI, but also in terms of the culture wars that, of course, underlie the whole campaign, the presidential campaign that happens in 2040 and so on.
Did you use any of the available AI tools to help in the formation of this book?
The short answer is no, I did not. I did, when they started coming out, try playing with them for a couple of different things, and writing was one of them. And honestly, they were completely useless, which did not surprise me, because of all the hard things for generative AI to do, I think writing a good novel is probably the hardest. Writing a short story is easier, making videos is easier, etc., etc. Making a good movie from beginning to end is hard. A novel is probably the hardest, because in the novel, you have you have to maintain consistency over 200 pages. And like, consistency is not the forte of generative AIs of today. Also, some things you can get away. I mean, let me put it this way. What are the killer apps of Gen AI? Writing code is one, but again, code within certain limits. Writing what you might call shallow text, right? Stuff that nobody's going to read very carefully, that's superficial. That's great. But a good novel is the opposite of that. It goes deep. It deeply reflects some reality. And, ChatGPT has no clue about any of that. And also, a good novel is very well written on a sentence-by-sentence basis. For example, writing a really good commercial tagline is also really hard. It's very short, but it really has to nail something really well. And generative AI doesn't have the discernment or the depth or the true creativity to do that. So no, I mean, like, I didn't think it would work, but I thought, well, just out of curiosity, let me try, and I haven't done this more recently, and of course they've improved. But honestly, I felt that it would waste my time more than it would save it. So no, I didn't use it for that.
Just a couple of more questions. What do you find the most surprising out of the things that come out? So you see it from Google, especially, and OpenAI. They have this daily sort of announcements, whether it's video generation. There's this advanced mode with vision capability. There's music generation. Notebook. There's Notebook LM from Google that they added an enhancement where it can look at research and things like that and give you sort of an interesting sort of take on it. But it has a podcast capability where now they added the ability where you could interact with the two podcasters who are AI generated. Their Sono and their music generation, which is now in their 4th edition. It's becoming much more capable and what it's doing. What are the things that you think are the most interesting to you out of the the plethora of announcements that are made almost daily, right, from different groups. So
you asked what is most surprising and what is most interesting. Those are actually slightly different things. I would actually say so. ChatGPT was a surprise when it happened. Famously, it surprised most of all the OpenAI folks themselves, who had no idea that that would take off, right? It was just a way to gather data, and boy, have they been gathering data ever since. But in a way, if you just extrapolate the progress of language models with the size of the data and compute available from the 50s to now, there's no surprise anywhere. This is something that I think is very underappreciated. Even if you've ever played with Ingram models, the simplest language model that is just Ingrams, right? Predict the next words from the previous two, or three, or four, or five. As the N goes up, you suddenly start getting way better. Right? This is what Google discovered with their spell check in 2000 that really got them into machine learning. And then there was Google Translate and whatnot. They were all based on statistics. The more data you build your models on, the model gets shockingly better, right? Even the Ingram models were already writing coherent English. My kid, when he was, like several years ago, he wrote this Markov bot that generated a plausible sounding, abstract of a journal paper. He showed it to me and said, like, what do you think? I said, like, yeah, this is the usual. It fooled me. The abstract fooled me. And this was just a 2-gram model. Sorry, a trigram conditioning on two things, right? So extrapolate that today, and why wouldn't it be writing whole pieces of text, like whole essays and whatnot? Like, that's exactly what you would predict and would fully for longer and whatnot. Now, this is not to minimize the technical contributions. Precisely the key contribution of transformers is that it lets you condition on a very large N while defeating the exponential. Like, the problem, of course, is that as the N goes up, the data and the compute that you need goes up exponentially. Transformers are a clever way to pick which previous words you want to condition on, right? But so there has been real technology to make this happen. But if you just look at the curve of language models getting better, there is no surprise. There's nothing to be surprised about, right? Of course, I didn't predict, and nobody predicted that thing would happen at that time. But if you zoom out, right, and again, the details of these curves, are very random. But if you zoom out if you look at Llama before, right, there was this guy saying it was sentient and whatnot. So, like, clearly you could see that, things were already starting to happen. So I think the larger point on the question of surprises, there have been no surprises. And a lot of the stuff that has happened since, a lot of really good stuff, right? Again, not to minimize that, is not that surprising. Like, for example, a lot of the generative AI, you went from, Ian Goodfellow with guns, making these noisy, very small pictures, and then they got larger and more detailed, and now it's video. I'm like, this is all great, but it's, it's all a very logical sequence of things get better, the algorithms improve, you put more compute behind them, so not too many surprises, right? Interestingly, right, now again, looking forward, which is really what I care about, like, will video generation, get really good? It'll get better. Where is the knowledge of the physical world that lets people not have 6 fingers or make impossible motions? That's still a problem, right? So we're not there. Is better video generation going to get us to AGI? I don't think so. This saying that vision is controlled hallucination, which is very true, right? We got the hallucination part. Where's the controlled part, right? Maybe all that diffusion technology and whatnot is a part of the solution, but we need to bring in the other parts, and I think people will, right? But I think video generation per se, in some way, the goalposts have changed, right? People look at these things that are basically computer graphics or demos or whatever as evidence of AGI, but we shouldn't lose the side of the fact, like, no, AGI is problem solving. It's understanding the world. It's et cetera, right? So we need to keep that in mind. What is interesting, I think, is like, what Google has been doing in terms with LM and so on is, I think this is a good direction to go. And I like that. I like what they've done in terms of, I think, how will AI become useful, right? Is by letting you do a lot of these tasks, partly, to take the automation further, the automation of your daily work, right? Today, we all use spreadsheets and word processors and whatnot. And AI, I think, is going to be the next generation of this, which, the sooner it comes, the better. So I like the stuff that is going in that direction. Having said that, for example, the podcast, it's very fun and entertaining, but if you kind of know where you are in terms of audio and in terms of text generation and whatnot, generating those podcasts, it was a great idea in terms of doing a successful demo, right? It's very important in AI, if you're coming today to do good demos. Again, the whole idea in 2040 is that the demo they come up with is a presidential candidate. So it's very successful as a demo, but it wasn't, going back to the surprising part, it wasn't surprising to me that at this point you could do something like that.
So Pedro, we're down to our last really literally minute. We've covered a lot of different areas. We entered with so your viewpoint of where things are going, the different players that are out there. We looked at the landscape. You were always saying that it's got to be not just a simple one sort of model solution. It's a multi sort of approach, and you've been a proponent of that your entire career, right? So. And even where things are going, you're really saying there, it's the master algorithm, right? It's this combination. You give them some really thoughtful viewpoints on the different researchers that are out there as well. This book sounds really interesting, the 2040 book. Across all of these, and you've been personally very successful. You've got the McCarthy Award. You've got the Innovation Award. You've been made a fellow of the AAAS, AAAI. I mean, your master algorithm was huge success, and now you're able to sort of focus full time on your research, and that's why you went to emeritus status. So it's been an interesting journey for you. What recommendation or question do you want to leave the audience?
Very good. So let me just make one quick point before that. The master algorithm is not just multi-algorithms. It's not just a combination of algorithms. There's a lot of that. My argument is that we need a unification. So I do think there is one model at the end of the day that will, maybe more than one, but just think like there's many versions of a Turing machine, right? There's many Turing complete languages, but the Turing machine concept is very important. I do address that notion in the master algorithm, like, can we just combine pieces of different things like people do in your symbolic active? And the answer is no. It's not just a question of like, I have a symbolic thing that calls neural as a subroutine or vice versa, or combining many different models. That is the easy route. And it's better than, and it's really what people do in practice. That's what people do all the time. But again, this is very different from, for example, Maxwell unifying electricity and magnetism with his equations and discovering that light is also electromagnetism. That is unification. He's saying like, it's not electricity and magnetism. They're just two facets of the same thing. In fact, today we know that magnetism is just a relativistic effect of electricity. So that's what I mean by the master algorithm. It's actually one model. Again, I make this joke in the master algorithm, from the Lord of the Rings, like one ring, right? We don't need 7 rings. It is one ring. So to your question, what is my advice to people? My advice to people is, my number one piece of advice is like, whatever you do, whatever your profession is, whether it's AI or computer related or not, the future belongs to the people who know how to use AI in their domain. We AI folks are having a lot of fun today playing in everybody's backyard because we're the ones who know AI. So we get to go into education, into medicine, into business, into, drug design, climate science, et cetera, et cetera. It's great. But in the long run, right, like this is, I think, a temporary thing, right? The future belongs to the next generation of, for example, people in biology that when they got their PhD or even their, bachelor's in biology, they also learned a lot of AI. And they know how to apply AI to biology or business or whatever, just natively, right? They have AI literacy, like today you have computer literacy, or like you know how to read and write. That is where the future, and honestly, the people in those areas today can't do that because it takes the AI. Like the old lab coat biologist doesn't know how to do, AI models for biology. And we still need the lab coat, but to cure cancer, we need the AI models, for example, right? So it's neither the AI folks nor the folks in the field that are going to solve the problem. It's the people in the field who know enough AI, right? So it's not man versus machine. It's man with machine versus man without. So my advice to everybody is like start learning some AI. Like, for example, I wrote the master algorithm for that purpose. And again, 2040 takes that further. Start understanding AI at the level, doesn't have to be at a very deep technical level, but at the level like how can you use it in what you do in ways that people haven't before? And then you'll automate part of your job, which means you'll get to focus on the more interesting parts. You'll do it better, right? And then at the end of the day, you'll probably have more money and more job offers and more success and more everything than now. So AI is a huge opportunity, and it's actually for every one of us to seize it.
Yeah, and I guess ultimately people should read both of your books.
I think reading those books is a good starting point, and that's why I wrote them, but it is a starting point. You also want to do things like, for example, take some of the online, like Andrew Ng's Coursera course is very nice, right? He has a whole series of them, so you can then pick and choose. Another thing that I recommend to people is, get your feet wet, start playing with things. Enter Kaggle competitions, for example, right? Most Kaggle competitions are not won by experts. It's amazing. They won, like I had a student in one of my courses, an evening course, who was in industry. I gave them the Netflix prize. This was many years ago as a project. He went on to be one of the winners. Starting from not knowing any machine learning, 6 months later, he was one of the winners of the Netflix prize, right? So you can do this.
So great advice, Pedro. I recommend the audience follow your work and continue to look at anything you do that is discoverable. You're an amazing contributor. Continue to have a outsized impact on the industry, but also on your field and more. So thank you for coming in and sharing your insights with my audience.
Thank you. This was fun.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.